Hi, Algebra 2. This is Unit 6, Lesson 5, and today we're going to do factoring completely. Alright, so we're going to start with this little warm-up where we're first going to multiply, just so you can see when we turn around and factor in a second where this all came from. So I have three expressions to multiply. I'm first going to do these two middle ones right there, the binomials. So I'm going to do FOIL. X times x is x squared. X times 7 is 7x. 4 times x is 4x, and 4 times 7 is 28. So remember, I always get four expressions. Those two middle expressions can be combined together. So I'm writing that middle step for you. If you don't need to write it, that's certainly fine. So this right here, these two binomials became x squared plus 11x plus 28. But I still have that 2 in front of there. So now the 2 gets distributed to everything inside. So I'm actually going to get 2x squared plus 22x plus 56. All right, let's try another one. So again, I'm going to start with just multiplying these two binomials in the middle. So that's going to give me 2x squared, and this will give me positive 6x and negative 5x. So if you can do that in your head in one swoop, that's certainly fine. But again, 2x times 3 is 6x, and negative 5 times x is negative 5x, so that's a positive 1x. And then my last term's negative 5 times 3 is negative 15. And now I still have that 5 hanging out in front that needs to get distributed to everything, so that gives me 10x squared plus 5x minus 75. All right, and I got one more to do. This one should be a little bit quicker. 3x minus 2 times 3x plus 2. So 3x times 3x is 9x squared. Now look what's happening. 3x times 2 is positive 6x, and negative 2 times 3 is negative 6x. They cancel each other out. And negative 2 times positive 2 is negative 4. Okay, so again, this is a difference of two perfect squares. And then 4x gets distributed out, so that's 36x to the cubed, and 4x times negative 4 is negative 16x. So in a second, we're going to start with the answers that I just found and work our way backwards and factor out. So the first step that we're going to see in this factoring completely is that you're always going to look for a greatest common factor. So to completely factor an expression means to write it as a product which includes binomials that contain no greatest common factors, or GCFs. All right, so let's look at this trinomial that I have, 2x squared minus 4x minus 6. It's already been factored for us. Both of these, okay, right here, 2x minus 6 times x plus 1 and 2x squared plus 2 times x minus 3, are correct factorizations. They want us to verify that both of these are correct. So all I'm going to do is I'm going to use my FOIL and multiply them out. 2x times x, 2x squared, 2x times 1, 2x, negative 6 times x, negative 6x, negative 6 times 1, negative 6. I always get my four terms, and those two middle terms can be combined together to give me a negative 4x. Okay, which is what I wanted, because look what I was started with. Now let's verify that the next one, 2x times x is 2x squared, 2x times negative 3 is negative 6x, 2 times x is 2x, and 2 times negative 3 is negative 6. I combine those two middle terms together, and I get negative 4x. Okay, so again, I'm just verifying that both of those are correct ways of factoring. Now, why are neither of these factored completely? If you look at both of these expressions, 2x minus 6 and 2x plus 2, each of them had a greatest common factor that could be factored out, okay? Each has a binomial that contains a GCF that can be factored out. All right. D, write each of these in completely factored form by factoring out the GCF. All right, so let's take I'm just copying down the 2x minus 6 and the x plus 1. That was one of my factors that I had in my binomials, and the other one, 2x plus 2 times x minus 3. So that's what I started with. Each of these, I want to take that binomial that had a GCF in it and factor it out. So I'm going to factor out each of these. So in the first one, I have 2 is the greatest common factor, and I'm left with x minus 3. So all I did was take this, and it became this right there. And then the second one, 2x plus 2, I'm going to factor out a 2, and I'm left with x plus 1. And you can see these are equivalent to each other. All right, both are equivalent because multiplication, I can always use the commutative property. So both are equivalent. They're just written in a different order. But multiplication is commutative. All right, if I do 4 times 9 is 36 and 9 times 4 is 36. It doesn't matter the order in which I write. So they're just written in a different order. All right, so when we factor completely, basically we're going to look for the greatest common factor first, and then what's left, I have to look to see if it's a trinomial if I can factor it, or if it's a difference of two perfect squares I can factor. But the first step always is to look for the GCF. So when I'm factoring completely, if you want to write this down, the steps are look for the GCF, and this is always with factoring. Look to see if there's a GCF. If there is, factor it out. And then what's left, look to see maybe if it's the difference of two perfect squares or if it's a trinomial that you can factor. But you're always just looking for the greatest common factor. All right, so let's practice that. So in A, look at my expressions. I got 4x squared plus 12x minus 40. Now this is a trinomial. The last term doesn't have an x, so I obviously can't factor out an x, but let's look at the numbers, 4, 12, and 40. What's a number that's in common to all of them? Well, 4 is. So I'm going to factor out a 4. I'm going to divide out a 4 from each expression. So I'm going to be left with x squared, factor out a 4 from 12x, and I'm left with 3x, and factor out a 4 from negative 40, I'm left with negative 10. So now this trinomial right here is going to be able to get factored. The 4 will be hanging out in front, so just ignore that. And I'm going to factor x squared plus 3x minus 10. So I'm looking for numbers that multiply to 10 and add up to 3. Well, 5 times 2 is 10, and I can get a 3 out of 5 and 2. I want a positive 3, so this is a positive 5 and a negative 2. And that is now factored completely. Let's look at B. I have a binomial. Well, both of those terms have a 6 in common, so I'm going to factor out a 6, and I'm going to be left with x squared. I'm going to divide out a 6 from 24 minus 4. Now this should be, familiar to you. This is a difference of two perfect squares. So I set up my parentheses, and this is going to be x minus 2, x plus 2. All right, try C. 2, 20, 50. Well, it looks like I can only pull out a 2, and then I'm left with x squared plus 10x plus 5. 2 hangs out in front. X squared plus 10x plus 5. Actually, I messed that up. Sorry about that. I'm just looking ahead. I'm factoring out a 2, so 50 divided by 2 is 25. That's a little bit better. The way I had it, you wouldn't be able to factor it. So x times x is x squared. I'm looking for numbers that multiply to 25 and add up to 10. Well, 5 times 5 is 25. And I want it to be a positive 10, so positive 5 times positive 5. Factored completely. 75 minus 3x squared. All right, 75 and 3 are both divisible by 3. 75 divided by 3 is 25. Negative 3 divided by 3 is negative x squared. I can write the 1 if I need to, but I don't have to. And 25 minus x squared is the difference of two perfect squares. It's just written backwards, but 5 times 5 is 25, and it's a negative x and a positive x. All right, so just be careful on that because it's written backwards. It's the x's that have the negative signs. All right, so now exercise 4 is just a little bit trickier because it's going to be, the trinomial will have a coefficient there. So again, we use that guess and check. But I get 10x squared plus 55x minus 105. So all of those numbers are divisible by 5. When I factor out a 5, I'm left with 2x squared. 55 divided by 5 is 11x. And 105 divided by 5 is negative 21. So again, the trinomial that's left is a little bit harder to factor. The 5's just hanging out in front. Ignore it. 2x times x is 2x squared. I'm looking for numbers that multiply to 21. Okay, and add up to 11, but whatever number I put here is actually multiplied by that 2, so you got to be careful. So I'm really just going to guess and check. I only got 1 and 21 and 3 and 7 to guess and check on. So just sort of like without even writing them, you can put the 3 and the 7, or I'll write them because I can erase them, but say I put 7 here and 3 here and just test it out. Well, that gives me a 7x and a 6x because the 2 is multiplied by the 3. 7x and 6x, can that give me 11? Nope. All right, so let's erase those. And let's flip-flop them around. Let's put the 3 here and the 7 here. All right, well, again, whatever number is written there is actually multiplied by 2. So that's 14x and 3x. Can that give me an 11? Absolutely. If the 14x is positive and the 3x is negative. So again, this is just guess and check, and that's my answer. All right, 12x squared plus 57x minus 15. These are actually all divisible by 3. So I'm going to factor out a 3, and I'm left with 4x squared. 57 divided by 3 is 19x, and 15 divided by 3 is negative 5. Oops, I don't know what I wrote there. And now this is definitely a little bit harder because my question is it 2x times 2x to give me 14x squared? Well, I have to check that out. And the factors of 5 are actually only 1 and 5, so there's not a lot to check out. If I put a 1 here and a 5 here, that gives me 2x and 10x, and 2x and 10x do not give me 19. All right, so that's wrong. Let me get rid of the 2x and the 2x. Oops. And now I'm going to try 4x and x. Again, it's just 5 and 1. Oh, look, if I put the 5 here, 4 times 5 is 20x, and I put the 1 there. I want it to be a positive 19, so it's going to be a positive 20x and a negative 1x. And that's my answer. So you do just have to play around. Sometimes it's a little bit more involved. All right? So I think that's enough. If we have extra time with our practice tomorrow, we'll come back and do these two. But we'll